Hi, it's Mrs. Harmison here with part 1 of your 3F chemistry notes over limiting reactants. Let's get started. To find a limiting reactant, you must start with a balanced equation. To balance this equation, we are going to make a list of the elements, and then we're going to write down how many of each element are on each side. There's 1 magnesium, 2 bromine, 2 aluminum, and 3 sulfur on the left. On the right, there's 1 magnesium, 1 sulfur, 1 aluminum, and 3 bromine. Since we have a 2 and a 3 on the bromines, we're going to get those to 6. So we'll put a 3 here to get this one to 6, which also changes the magnesium to a 3. To get the bromine over here to 6, we'll put a 2 before the aluminum, which makes the bromine 6 and the aluminum 2. And then magnesium and sulfur each need a 3. You're also going to need to know which ones are the reactants and which are the products in a chemical equation. On the left side, you will find the reactants. On the right side, you will find the products. You will also need to remember how to calculate molar masses using the periodic table. To do this, we're going to look at the periodic table, and specifically, we're going to look at that bottom number. I always round my molar masses to 2 decimal places, so magnesium will be 24.31 grams per mole. For magnesium bromide, we're going to take 1 times magnesium's mass plus 2 times bromine's mass. And when we type that in, we get 184.11 grams per mole. Notice when I calculate my molar mass, I do not multiply by the coefficient. I went ahead and calculated the molar masses of each of these compounds. We are going to need those to do the problems. Okay, so our balanced equation gives us the mole ratios that we need to do conversions. So in this balanced equation, we can see that 3 moles of MgBr2 are equal to 1 mole of Al2S3, and that's also equal to 3 moles of MgS, which is also equal to 2 moles of AlBr3. We can also use molar masses for a conversion factor. So we could say that 1 mole of MgBr2 is equal to 184.11 grams of MgBr2. You can do that for any of these other compounds as well. Okay, so here is the type of a problem you would have if you're trying to do limiting reactants. It says if you start with 0.75 moles of each reactant, which is the limiting reactant and which is the excess reactant. So the first thing we're going to do is write down our givens. So we have 0.75 moles of each reactant. The reactants are the ones on the left side. So we have MgBr2, and we have also 0.75 moles of Al2S3. All right, and what we want to do is we want to pick a product. So we're going to pick one of these products. I'm just going to pick this first one. We are going to convert each of these givens to moles of this product. So we're already at moles of magnesium bromide. We want to get to moles of magnesium sulfide. When we are going from moles of one substance to moles of another, we're going to use a mole ratio. So the mole ratio in this case is 3 moles of magnesium bromide to 3 moles of magnesium sulfide. So moles of magnesium bromide are here. Down here we write moles of magnesium bromide, and the mole ratio for that is 3. Up here we're going to write what we're trying to get to, which is moles of magnesium sulfide, and that one is also 3. So when we take 0.75 times 3 divided by 3, we end up with 0.75 moles of MgS. For the second one, we have moles of Al2S3 here, so down here we need moles of Al2S3. We look at our mole ratio and see that there's only 1 mole of Al2S3 in the balanced equation. We're trying to get to moles of MgS, so up here we'll write 3 moles MgS. We take 0.75 times 3, and we get 2.25 moles of MgS. Now, when you're doing this, you have to make sure that you go to the same product for both of your givens, because you're comparing which one of these givens would make the least amount of a certain product. So we're going to look at these two numbers, 0.75 and 2.25, and we are going to see which one is smaller. Whichever one is bigger, we're going to cross it out. We will not use it at all in any parts of any future problems. And we're going to put a cloud around the number that is smaller. The reason I'm putting a cloud around that is because in the next lesson, when we are doing a little more complex problems, we are going to be using this number as our starting point for a lot of different things. However, to find out which is the limiting reactant, we just come back to the reactant that gave us the smaller number. So we'll say MgBr2 is limiting. And therefore, that makes our other reactant our excess. So we'll say Al2S3 is the excess reactant. And what this means is that all of the MgBr2 is going to be used up. And then there's still going to be some of the Al2S3 left over after the reaction goes to completion. And this problem is very similar to the last one, only instead of starting with moles, we're starting with grams. So we have 4 grams of MgBr2, and we have 1.5 grams of Al2S3. Okay, now as always with picket fences, we want to look and see what unit we have right here and put that same unit down here. So I'm going to put grams of MgBr2 down here. The only time we put grams into a picket fence is when we're using the molar mass. So we're going to put 184.11 grams down here. And then the molar mass is always equal to 1 mole. So we'll put 1 mole of MgBr2 up here. And we're going to do the exact same step down here, only we're using the molar mass for aluminum sulfide. So we'll say 150.14 grams of Al2S3 is equal to 1 mole. Okay, so if we stopped right now and worked this out, we'd have moles of MgBr2 and moles of Al2S3. But to find the limiting reactant, we need to get to moles of a product. So we'll pick a product. And I picked the first one. I almost always pick the first one. So I want to get to moles of MgS from moles of MgBr2. I'm going to use my mole ratio. So down here, I'm going to put 3 moles of MgBr2 because that's what's in the equation. And then up here, I'm going to put 3 moles of MgS because that's what's in the equation for magnesium sulfide. Down here, I'm going to do the exact same step, only I'm going from moles of aluminum sulfide, 1 mole, to moles of magnesium sulfide is going to be the same 3. All right, when I work these out, I type it into the calculator, multiply by what's on top, divide by both of the things on the bottom. On this one, be careful that you type in 4 times 3 divided by 184.11 divided by 3. Don't multiply by that 3. It's on the bottom, so we divide. And when we type these in, we get 0.021726 moles of MgS and 0.02997 moles of MgS. Again, it's very important that these are the same compounds. You have to compare the same compound. So we're going to look at these and see which one's smaller. When they're decimals, you have to pay close attention. 0.021 is smaller than 0.029. So we're going to put a cloud around this to be used a lot later. We're going to X out this one because we won't be using it later. And we'll go back to our reactant and say MgBr2 is limiting and Al2S3 is the excess reactant. Again, this means that magnesium bromide will be the first to run out, while there will be some aluminum sulfide left over after the reaction has gone to completion.